Hello everyone, welcome back to our channel. In today's video we are going to delve into an important and responsible topic: how to protect your Wi-Fi network from potential attacks. We understand the importance of safeguarding your personal and professional data from unauthorized access, and that's why this video is essential for anyone using a wireless network. Before we get into the details of how to secure your Wi-Fi, it's crucial to understand how attackers might gain access to your network. This knowledge will help you implement the right measures to protect your network effectively. It's worth noting that the technique discussed here should only be practiced in a controlled environment, such as your own lab network, and not on any unauthorized network. Our goal is to educate you on potential security risks and how to mitigate them, not to promote illegal activities. But before we jump into the practical steps, it's crucial to understand the theory behind it. Remember, this video is for educational purposes only. Please like, subscribe, and share it with your friends to spread awareness about Wi-Fi security. Let's get started. What is WPA? Wi-Fi Protected Access, or WPA, was developed to address the security vulnerabilities found in WEP encryption. WEP, or Wired Equivalent Privacy, had a major flaw: the short initialization vector, which was sent in plain text within each packet. This short IV made it possible for attackers to exhaust the unique IVs quickly, especially in a busy network. Once exhausted, attackers could capture packets with repeated IVs and use statistical attacks to crack the WEP key. However, WPA was designed to overcome these issues. In WPA, each packet is encrypted with a unique, temporary key, which means that no matter how many packets we capture, they will not provide the same kind of information that could help in cracking the encryption key. This significant improvement made WPA a much stronger and more secure protocol compared to WEP. How does WPA work? Each packet in WPA is encrypted with a unique, temporary key, unlike WEP, where IVs are reused. Even if we capture 1 million packets, each will have a different IV, rendering them useless for traditional statistical attacks. WPA2, the successor to WPA, operates on the same principles but uses a more advanced encryption algorithm called CCMP, which stands for Counter Mode Cipher Blockchaining Message Authentication Code Protocol. Understanding the handshake. The key to cracking WPA encryption lies in capturing the handshake packets. When a device connects to a WPA-protected network, a process called the four-way handshake occurs. During this handshake, 4 packets are exchanged between the device and the access point to authenticate the connection. These handshake packets contain the necessary information to potentially crack the WPA key. Here's a simplified breakdown of the four-way handshake. Authentication request. The device sends an authentication request to the AP. Challenge from AP. The AP responds with a challenge. Device response. The device sends a response, proving it knows the WPA key. Final authentication. The AP confirms the device's response and allows the connection. By capturing these handshake packets, we can use a word list in conjunction with tools like Aircrack-ng to test each password in the word list against the handshake data. This process involves checking each password to see if it can successfully decrypt the handshake packets, ultimately revealing the WPA key. What do we need to crack WPA? To crack a WPA encrypted network, we need 2 main things. Captured handshake. This is the 4-packet sequence exchanged when a device connects to the network. Wordlist. A comprehensive list of potential passwords that we can test against the captured handshake. Now that we've covered the theoretical part of WPA encryption, it's time to dive into the practical steps. First of all, I will guide you through switching your wireless interface to monitor mode, an essential step in capturing the handshake packets. If you're familiar with this process from our previous videos, feel free to skip ahead. For everyone else, let's get started. First, open your terminal. To perform the necessary actions, you need root access. Enter the command sudo su. This command grants you superuser privileges, allowing you to execute commands with administrative rights. Next, let's check the current mode of your wireless interface. Run the following command, iwconfig. This command displays your wireless interface settings. You'll see that your wireless interface, usually named WLAN 0, is currently in managed mode. Before switching modes, you need to bring down the wireless interface. Execute the command ifconfig wlan 0 down. This command temporarily disables your wireless interface, preparing it for mode change. To ensure a smooth transition, you must kill any processes that might interfere with the mode switch. Run the command earman-ng check kill. This command terminates any conflicting processes that could cause issues while setting the monitor mode. Now let's switch the wireless interface to monitor mode. Execute the command iwconfig wlan 0 mode monitor. This command changes the mode of your wireless interface from manage to monitor. In monitor mode, your wireless interface can capture all packets in the network, not just those addressed to it. After switching modes, you need to bring the wireless interface back up. Run the command ifconfig wlan 0 up. This command re-enables your wireless interface, now operating in monitor mode. Finally, let's verify that the mode change was successful. Run the command again, iwconfig. You should see that your wireless interface, wlan 0, is now in monitor mode. Congratulations! You've successfully switched your wireless interface to monitor mode. Now that we've switched our wireless interface to monitor mode, it's time to capture the WPA handshake. This step is crucial for cracking the WPA key. In this section, we'll use aerodump-ng and airplay-ng to capture the handshake packets from a target network. First, let's capture all the networks around us using aerodump-ng. Open your terminal and enter the following command, aerodump-ng wlan 0. This command will display a list of all the wireless networks within range, along with their respective details such as BSS ID, channel, and encryption type. Identify your target network from this list. In our example, the target network is TechSky. Now, we'll focus on capturing the handshake packets from the target network. To do this, run the following command, aerodump-ng bssid, write the MAC address of the target network. Channel, write the channel number here. Write WPA_handshake, which is the name of our captured packets file. WLAN 0, which is the name of our wireless interface. Once you run this command, aerodump-ng will start capturing packets from the target network, displaying both the network details and any connected clients. To capture the handshake, we have two options. Passive capture. Simply wait for a device to connect to the network. When a device connects, the handshake packets will be transmitted, and aerodump-ng will capture them. Active capture via the authentication attack. Force a connected device to disconnect and reconnect, thereby triggering the handshake. This method is faster and more reliable. Let's explore this method in detail. To perform a deauthentication attack, we'll use airplay-ng. This attack will momentarily disconnect a device from the network, causing it to reconnect and generate the handshake packets. Run the following command airplay-ng, deauth4, indicates 4 deauthentication packets. A specifies the MAC address of the target AP. C specifies the MAC address of the client device to be disconnected. WLAN 0 is the wireless interface in monitor mode. To find the client MAC address, look at the list of connected devices in the aerodump-ng output. After running the deauthentication command, the target device will disconnect and then reconnect to the network. During this reconnection, the handshake packets will be transmitted. Check your aerodump-ng terminal to see if the handshake was captured. You should see a message indicating the capture of the WPA handshake. Once the handshake is captured, you'll see a line in the aerodump-ng output indicating a successful capture, typically shown as WPA handshake BSSID of the target access point. Congratulations! You've successfully captured the WPA handshake. Now that we've successfully captured the WPA handshake, the next step is to create a word list to crack the WPA key. A word list is a compilation of possible passwords that the Aircrack-ng tool will use to try and crack the WPA encryption by comparing each word in the list against the captured handshake. The effectiveness of this step relies heavily on the quality and comprehensiveness of the word list. The word list is essentially a brute force attack method where every word in the list is tested against the captured handshake until the correct password is found. If the password is included in the word list, Aircrack-ng will successfully crack the WPA key. However, If the password is not in the word list, the attack will fail. Therefore, the more comprehensive the word list, the higher the chances of success. To create our word list, we will use a tool called Crunch. Crunch allows us to generate custom word lists based on specified criteria, such as the length of the passwords and the characters they contain. For this demonstration, we will create a word list that consists of passwords made up of only 2 characters, 1 and 2. The passwords will be 8 characters in length. Now, open your terminal and run the following command. Crunch, it is the name of the tool. 8 specifies the minimum number of characters for the password to be generated. And next 8 specifies the maximum number of characters for the password to be generated. In our case, we are only interested in generating passwords of length 8. That's why the minimum and maximum lengths of passwords are the same. 1, 2, specify the characters that we want to use in the password. wordlist.txt. Option specifies the file name where the passwords are going to be stored. After running the command, Crunch will generate the word list and display its progress in the terminal. The output will indicate the total number of generated passwords, the size of the word list file, and where the file is saved. For our example, with a password length of 8 characters, and using only 1 and 2, Crunch will generate 256 possible combinations. Our word list file, wordlist.txt, will contain all these combinations and will be approximately 2 KB in size. This small size is due to the limited character set and short password length in our example. In real-world scenarios, where passwords are more complex and longer, the word list file can grow significantly in size, potentially reaching gigabytes or even terabytes. We are now at the final step of our WPA and WPA2 cracking process. In this step, we will use Aircrack-ng to crack the WPA key using the handshake we captured and the word list we created in the previous steps. This process involves testing each password in the word list against the captured handshake until the correct password is found. Let's dive into the details of this process. To crack the WPA or WPA2 encryption, Aircrack-ng uses a process that involves creating a pairwise master key for each password in the word list. The PMK is generated using an algorithm called PBKDF2, which combines the password and the SSID of the target AP. This PMK is then compared to the captured handshake. If the PMK matches, the password used to create it is the correct WPA key. If it doesn't match, Aircrack-ng moves on to the next password in the word list. Before we start cracking, ensure that you have the following files ready. The captured handshake file, in this example, WPA_handshake-01.cap. The word list file, in this example, wordlist.txt. Open your terminal and run the following command, Aircrack-ng. Here is our captured packets file, WPA_handshake-01.cap. The generated word list file, wordlist.txt. Press Enter to run the command. Aircrack-ng will start processing the word list and testing each password against the captured handshake. The tool will display the progress in the terminal, showing the current password being tested and the overall progress through the word list. If the correct password is in the word list, Aircrack-ng will display the WPA key when a match is found. We've now completed the process of cracking the WPA key using Aircrack-ng and a word list. By capturing the handshake and creating a comprehensive word list, we've demonstrated how Aircrack-ng systematically tests each password to determine the correct WPA key. In our previous section, we explored how hackers attempt to crack Wi-Fi passwords. Now it's crucial to focus on securing our Wi-Fi network to prevent such attacks. Let's dive into the steps you can take to safeguard your Wi-Fi. To begin securing your network, you'll need to access your router's settings page. Every router has a web-based interface where you can configure its settings. Start by finding the IP address of your computer. Open a terminal and run ifconfig-lon0 to locate your IP address. Note down the highlighted part, which is your computer's IP. Next, open a web browser and type 192.168.1.1 in the address bar. This is typically the IP address of your router. If your computer's IP ends in .2, change it to .1 because that's usually the router's IP in the subnet. This will take you to the router settings page. On the router settings page, you'll be prompted to enter a username and password. This information is usually provided by your internet service provider or written on the sticker attached to your router. Enter these credentials to access the settings. Once logged in, it's important to strengthen your router's security settings. If possible, connect to the router using an Ethernet cable to prevent potential deauthentication attacks. Modify settings such as encryption type, preferably WPA2 or WPA3, Wi-Fi password, and other security configurations as recommended by your router's manufacturer. Every router model has different settings, but the process of accessing and modifying them remains similar. Ensure your Wi-Fi network is secure by making these necessary adjustments. But first of all, we will generate a strong Wi-Fi password. Open a new tab in your browser and search for a strong Wi-Fi password generator. One recommended site is Rotten Wi-Fi, or choose any trusted generator. Select a password length of at least 8 characters and include all character types uppercase, lowercase, numbers, and special characters. Click the Generate Password button and copy the generated password. Now that we've generated a strong Wi-Fi password, it's crucial to store it securely. Here's how you can do it. Firstly, open your File Explorer and create a new text file. Name it something memorable, like Wi-Fi_password. Open the file and paste the copied password into it. Be sure to save the file by pressing Ctrl+S. Next, open your web browser and navigate to Google Drive. If you haven't already, sign in to your Google account. Upload the password file Wi-Fi_password.txt, your Google Drive. This ensures your password is securely stored in the cloud, accessible only by you. By saving your Wi-Fi password on Google Drive, you no longer need to memorize it. You can access it securely from any device with an internet connection. This method provides convenience while maintaining security. Now that we've generated a strong password and securely stored it on Google Drive, let's enhance our Wi-Fi security by updating our router settings. Firstly, return to your Wi-Fi router settings page. Navigate to the Wireless tab and locate the security settings. Here, you'll see your current wireless security information, including the SSID, which is the Wi-Fi network name, and network authentication currently set to WPA PSK. To enhance security, update the network authentication to WPA2 PSK. Click on the Authentication drop-down menu and select WPA2 PSK. Now in the password field below, click to display the current password. As you can see, it's recommended to use a strong password, so let's paste the new password we generated earlier into this field. Click to display the password again to confirm it's correct. Finally, click the Apply or Save button to save your changes. Your new Wi-Fi password and security settings are now updated to WPA2 PSK, ensuring stronger protection for your network. Now let's dive into an interesting experiment to understand the complexity and security of our new Wi-Fi password. We want to see how long it would take to generate a word list of 8-character passwords including only lowercase English alphabets, and how much memory it would cover. Firstly, open your terminal and use the Crunch tool to generate a word list containing all possible combinations of 8-character passwords using only lowercase English alphabets. By running this command, Crunch will create a word list that includes all possible 8-character combinations of lowercase letters. After running the command, you can see that the size of the file is approximately 1 terabyte. This huge file size demonstrates the immense number of possible combinations, even with just lowercase letters. Now imagine generating a word list that includes all uppercase and lowercase alphabets, numbers, and special characters. The complexity and size of the word list would increase exponentially. The storage required for such a word list would be impractically large, possibly running into petabytes or even exabytes. The time taken to generate and use this word list would be incredibly long, making it impractical for attackers to use brute force methods. This experiment highlights the strength and security of your new Wi-Fi password. Even if an attacker managed to create a word list with random passwords, the sheer size and complexity would make it extremely difficult and time-consuming to decrypt using tools like Aircrack-ng. By understanding these factors, you can see why having a strong, complex password significantly enhances your Wi-Fi security. Your network is now robust and well protected against potential attacks. Thank you for watching. If you found it insightful, please like, subscribe, and share it with others. Stay tuned for more security tips and experiments in our next videos.